Hey, I'm Jason, and in this video I'm going to show you how to add alternating ditch lights to a Kato SD70MAC. If you haven't watched my previous video on converting this locomotive to DCC, I'll put a link down in the bottom so you can watch that video first and see how I put the DCC decoder in this locomotive, and then now in this video I'll show you how we'll add the ditch lights. Alright, so let's get going. Okay, to do our ditch light conversion, you're going to need several things. You're going to need, obviously, your locomotive. You're going to need a decoder that is capable of doing an alternate function, ditch light function. The TCS decoders are great for that. It's a function. It's almost you can almost consider it built-in. This is the K1D4 for the SD70MAC. They actually put the wiring diagram right here, so as far as connecting up your LEDs are concerned, there's your connections right there. And then at the end of the video we'll talk about the programming side of things to get the decoder actually doing the function, and that is even very simple as well, and I'll show you that. Okay, so let's talk about what you need. Okay, so for the LEDs, you need 0603 or smaller. 0603 seems to be a pretty good size, fits pretty well, and it does a pretty good job for what we're doing here. I have white. These are white LEDs, and I will post a link in the bottom of the video to where I get these. The wire is actually solid wire wrapping wire, and it's 30 gauge wire wrapping wire. Wire wrapping wire, that's just a common term. That's not a brand or anything. This is OK Industries, which I don't even know if these guys are in business anymore. You can get wire wrap wire if you just search Google for wire wrap wire. If I can find a good link, I'll put it in the link description. I'll link the description in the bottom of the video. Alright, so I've already pre-prepared these. I took these two LEDs and I went ahead and soldered on two, I don't know, you could call them lead wires or whatever you want to call them. So these are all ready to go. Now, the one thing with these LEDs is there's no indication on them of what the cathode and the anode is, so it's really hard to tell which is which. I'm sure if I looked up the data sheet, it probably tells me the way it's oriented in the tape strip. The easiest thing for me was to just solder on the wires, and then I have a little 3.3 volt test power supply with a 1K resistor in line, and I use that and I just test it for polarity. As soon as I know what the negative side is, I take a Sharpie and I mark the wire black, so that way I know for a fact that that is the negative side of the LED, and when we go to wire this thing, it'll be correct, because once we wire it up, we won't have to go in and have to troubleshoot this thing. Okay, the other thing you'll need is two very short pieces of heat shrink. This is 1/8 inch heat shrink, and these pieces are about a 1/2 inch, but we may end up having to trim them eventually. So I'll start with 1/2 inch pieces. Try to find the type without the glue inside. You don't want the ones with the glue. This is just heat shrink, not glue. It's sometimes they'll call it lined adhesive or adhesive lined heat shrink. You do not want that. You want the stuff without the glue. And then to make this job a little bit easier, I use a little pair of diagonal cutters, a little tiny sharp pair like this, and also the tweezers are a big help as well. I want to caution you, if you're watching this and thinking about doing this, this is a tedious job, and it also requires a pretty skilled level with soldering, and I don't want to detract people from doing this, because I want people to do this stuff because it's a lot of fun. But if you're not comfortable with it, then please don't, because you could potentially damage your decoder, damage your locomotive, and I am not responsible for that. So I guess that's what I'm doing here, is I'm disclaimering this, that if you decide to do this conversion yourself and you screw something up, don't come back to me. Now, if you have some questions you think I can help, please post them in the comments below, and I will gladly do my best to try to help everyone. When it comes to the soldering iron, I have a couple different irons that I use. The particular iron that I am using is a Weller WSD51. It's temperature controlled, and temperature control is important because you don't want to be operating this at too high of a temperature. Right now I'm at about 650 Fahrenheit, and I'm not sure what the equivalent of that is in Celsius. but I'm using 650 Fahrenheit. I'm using a small, very small chisel tip here. I can get away with using a little bit bigger tip. Some people might need a smaller tip for this, but I've been soldering for over 25 years, and I do know what I'm doing. I'm a soldering instructor for NASA where I work, so I'm just caveating that. I'm not I'm not bragging. I'm just simply saying that I have been doing this a long time, and I do know what I'm talking about, and I do know what I'm doing. So, anyways, all right, enough of that. Let's get to it. So, let's push some of this stuff out of the way temporarily here. All right, so in the DCC conversion video, I showed how to pop the shell off. It's real simple. We'll do it again here. Just grab this bottom here, and you just kind of wiggle, and pop the shell, and the shell comes right off. But uh-oh, we got a problem here. Where we need to put the lights are up inside the shell here. The LEDs need to go up inside the shell. So what we need to do is we actually need to put this back together the way it was. And I'm going to do that real quick, and then I'll come back to you. Okay, so I'm back. Okay, I've put the shell back on. Now, what we really need to do is, what most people don't realize is that these Katos are actually, the shells are two pieces. You got the main shell, and then you've got the walkway that goes all the way around with the handrails and everything. That's all a separate piece that come together. They come together at that seam there. So what we need to do is we actually need to leave that walkway handrail part on the locomotive and just take the shell itself off. Now, what I tend to do is, I don't know if you saw that, but I hold this down here, and then I slowly, just kind of gently lift the shell up, and the shell will come loose. And then at the front, it's the same type of thing. And before I forget, these little grab irons here on the front, you have to pop them out because you don't want to rip those off. So these two little grab irons here, they're just pressed in. So if you just take a small flathead, they'll very gently come off. Alright. There we go. Okay. So now you see that the shells come off and the little walkway is still there. Now the little walkway, sometimes it will come loose on you, and you just pop it kind of back into place. So the reason I wanted to do that, separate those two, is this real piece right here. This is the crucial part that we're worried about. This is called light pipe. If you see where this light pipe comes up, you can see that it's very close to right in front of this LED on our DCC board. And because of that, when this LED is lit up, that light is captured by this little acrylic light pipe, and it actually will direct the light through it to the lights, to the ditch lights. And the ditch lights are just that. They're this acrylic plastic extended to the ditch lights. So this is good, and this is good for a lot of reasons. One, the ditch lights are already there, so we don't have to get into putting the LEDs inside of these little ditch light housings, which would be very, very difficult. The good news is that we can use this little light pipe to our advantage. Right now it's connected together, so if I hooked an LED or shined an LED into it, it's going to light both of them at the same time. But we want to alternate them back and forth. We want to be able to light this one, then this one, back and forth. And to do that, it's very simple. We're going to take our little diagonals, and you're going to see that this splits. This when it comes down about halfway, it splits and Y's out. It branches out, and we can use that to our advantage. We are going to take our cutters, and we're going to cut that a little bit up, about midway up, about halfway up. I'm going to cut this. Turn this around, get a good angle on it. Okay, now that I've done that, there's what's left of our little light pipe piece. We don't need this. We can actually discard this now. But, and I'll try to hold this up, and hopefully the camera will focus on it. You can now see, hopefully you can see that there's two little pieces of that light pipe left sticking up, and that is going to be key for what we're doing here. Okay. Alright, so let's set that aside for a second, and let's draw our attention to the LEDs. So the LEDs we already talked about are pre-wired. We already pre-wired them with some of that wire wrapping wire. It's solid wire. In solid's okay. We don't have anything moving in here, so the solid's okay. What we're going to do with these heat shrink pieces is we're actually going to take these and we're going to set these about halfway so that the LED is about halfway inside of this piece of heat shrink. Okay? Right about like that. And then I'm going to take my my heat gun and I'm going to heat shrink this so that the LED is essentially captured. The LED is essentially captured inside there now. And you can see it's bulging out in the center a little bit, and that's where our LED is. But the important thing is that on the end here, we still have like a little hole, because the heat shrink does not close down on itself completely. It only closes down about half to 3/4. So what we want to do is we want to do that with both of them. Let that one cool. That's the other crucial thing. You want these to cool because we don't want it to deform when we go to use it. Okay, so there we go. Both of those are done. So we'll let these sit and cool. Okay, our heat shrink is cooled. So this this heat shrink, when it cools, it becomes a little bit stiff, which is it's perfect. That's really what we need. Okay. If you're using a TCS board, what you'll notice, and if you're using a TCS board with a Kato, anyways, and remember I can only vouch for those because that's what I'm using here. And if you look to the side here, there's actually a very slight gap between the frame and the board. You can just see it. We're going to use that to our advantage. So what I'm going to do is I'm going to take, and this is another reason why using really small, fine wire is good for this. So I'm going to take these wires and I'm going to actually thread them underneath the board and have them come out right here in this gap. There's a gap right here in the frame. Alright, so I'm going to do that there, and I'm going to do that on the other side as well. So I'm gonna thread both of these LED wires through. And sometimes you have to mess with it a little bit. You gotta straighten the wires out a little bit. Sometimes they go right on through, like that one. That one went right on through. No trouble. And just be careful. Just careful as you're threading them through. And whoops. Be careful with this frame piece. Just keep it in place. Okay. Alright, now that we've done that, what we're going to do is we're going to take these and we are going to push these down over those little acrylic light pipes that we left behind when we cut the other one off. Okay? And if this is a little small for you, use those tweezers. That's a big help. Just take your time, be gentle with it. Don't want to break anything. And what you want to do is you want to push these down on those little light pipes so that those LEDs inside there are essentially pushed right up against the ends of those light pipes. Because that way you're going to get the best transfer of light from those LEDs to those light pipes. It's going to give you the best, the best transfer. Okay. So hopefully you can see that now. Those LEDs and heat shrink assemblies are now pushed onto that acrylic, and that is it for that part of it. Now, the last thing to do now is to solder these onto the board. Now, I mentioned before that they actually give you the pinout right here, or the diagram, if you will. There's four small pads that are pre-soldered. There's actually a little bit of solder on each one of them already, which will help because we don't have to pre-tin that. We'll just pre-tin our wires and they'll solder right onto those pads. The first two, the two closest to the front of the locomotive, that's your positives, and the second two are your negatives, so we just have to keep that in mind. I like to solder the positives first because they are the closest, and then so essentially what we'll do is we'll solder these two on, and then the negatives will kind of jump over those two and get soldered to the second pair. Okay. All right. So this is where it gets a little fiddly if you're not comfortable doing this kind of work or haven't done this before. All right. What I'm going to do is I'm going to pre-cut these and strip these so that there's no real excess, because I really don't want any excess inside here if I can avoid it because of the space inside the locomotive. Or inside the shell. There's just not a lot of space for excess. So what I do is I kind of eyeball it. I take the wire, and I know that I need about this much. So I'm going to trim that. And I'm going to do the same thing with this one. Take this, I'm going to trim this. Okay. My negatives I'm just kind of keeping off to the side because I'm not doing anything with them just yet. Now we need to strip back just the slightest amount, just a tiny amount of wire insulation needs to come off of these. So to prevent myself from actually pulling the thing out of there, I'll actually take little needle nose pliers. I forgot to mention these in the beginning. Needle nose pliers will be helpful for this. So what you want to do is you want to hold that wire not too tight, because you don't want to crimp the wire and destroy it, but you need it tight enough. And then I take these and I just the slightest bit. I don't know if you can see that, but it's not even a 16th. It's probably a 30 seconds of insulation I pulled off of there. We'll do that with this one as well. Okay, there we go. Just the slightest little bit of insulation we pull off there. Alright, now when it comes to soldering, little or as little as possible is the name of the game here. So I've got some very, very small, I keep various gauges of solder here, but this is a real small stuff. This isn't even a 30 seconds, it's probably like a 64th, it's very, very small. Also, if you are working on electronics, I advise to get what is called eutectic or 6337 solder. That is really the best stuff to work with. I recommend it all day long, but that's what this is. So what I'm going to do is I'm just going to pre-tin these wires just a touch. Just get a little bit of solder on them. Okay? By doing that, that's going to be much easier to get these to stay in place. I'm going to try to show this the best I can anyways. If you take the wire and you kind of bend it down so that your pre-tin tip is kind of pointing down, this will be much easier to get to stick. Okay, there's one and two. Alright, I'll see. Hopefully, maybe the camera will show that. I don't know. Maybe. Hopefully you can see that there. So those two are now soldered in place on those pads. You saw how quick and easy it was. Not a lot. Doesn't take a lot of heat. That definitely doesn't take a lot of solder. The old saying, the bigger the blob, the better the job, is not the case here. Is not the case. And for the record, I've never agreed with that. That saying, I should say. But that's the soldering instructor in me coming out. Alright, now I'm going to do the exact same thing for the ground wires. Okay, I'm going to do the same thing. I'm going to strip just a little bit of insulation off these, just the slightest bit. Doesn't have to be much because those pads are so tiny. Okay. And again, I'll try to show that on the camera here. Hopefully that's focusing. But you can see all four have been soldered in place now on those four pads. Also, it's worth mentioning that this wire wrap wire is actually Teflon coated. Sometimes it'll be called PTFE, and that's important because when you heat this wire up, if it's not Teflon insulation, the insulation will actually shrink back. It'll melt and shrink back, and by using the Teflon coated stuff, that doesn't happen. So it makes for just a neater job and less opportunity for it to potentially short against something. So I mean, that's what the insulation is there for. It's to insulate. That's the whole point of it. So, all right, let's put this shell back on. And what you really want to do is put the front in first. There's a tab here. There's two tabs back here. Really want to get that first tab in. Just watch for the handrails, things like that, so they don't get in the way. You don't want to crush and damage anything. I can't stress enough how fragile these little locomotives really are. They're really fragile. And the only thing I need to do is put these little grab irons back in place. Okay, our physical conversion is complete. Now we just gotta program it. Okay, I'm gonna show you how to program the CV, or the control variable, to turn the ditch lights on. And I'm up in my training room, so sorry for the echo. So in order to make these ditch lights work the way we want it to, the alternating, that is in control variable 8, or CV8, and you program a 10 into it. So you can see 8802 has already been selected, and I'm showing this on NCE Power Cab. So we're going to go to Program on Main, 8802. We're going to do C, or 2 for CV. We want to program CV8, and we want to enter a value of 10. And that's it. That's all we have to do. We just escape out of there. Just to prove the headlights work. There's the headlights. Now, in order to turn on the ditch lights, we have to use functions 1 and 2. So 1 turns them on. So there we go. That turns them on. You can toggle them off or on. And then 2, along with 1 already on, makes them alternating. And there you have it. Alternating ditch lights. Well, I want to thank everyone for watching. And I know this is a long video, but hopefully after seeing the whole process, you understand why it does take so long to explain all of it and show it all properly in the steps that are required. So thanks for watching. Please subscribe for more train videos. They'll be coming soon, and we'll see you next time.